really, I wanted to just take you back a few days, basically. So the whole AECtech event is actually a 5-day event we made out of it. So we started Thursday and Friday with 2 days packed with workshops. So we had a couple of digital workshops, 130 participants, I believe, in total. So we got Andy, Yorgos, and some of the colleagues from Grimshaw presenting us the Interop Cube, looking at Rhino inside Revit, connecting that to Unity, do some simulations on the background, and actually get the results back into all of the virtual reality environments. The guys at KPF, they were showing us 2 workshops. One is looking at Rhino Compute through the API. The other one was more looking at some workflows and how to optimize curtain wall panels. Then we had Beam, another interoperability tool, quite specifically bringing the BIM into Rhino. Shape Diver, so we saw that presentation of Mathur. So really have a deep dive into the tools and looking how they were working. And we got some of our own folks looking into the core apps, going from 2D to 3D to 4D and back and forth, basically. I thought they were quite successful. I hope people enjoyed them. And then, as Charlie was saying, over the weekend, Saturday and Sunday, we actually had a full-on hackathon going all the way through. So I basically wanted to just show you a little bit of the results of that whole effort and what people came up with. I think it's quite innovative and quite a lot of work there. So what is a hackathon? First of all, it's time limited. So we basically, from Saturday morning to Sunday afternoon, we had 27 hours to work on those projects. Quite a few people signed up. In the end, we got 4 teams in total, built out of 21 participants. So they were working around the clock and around time zones, across different time zones. So we had a person from Japan, we had a few people in Europe, spread through the different time zones in Europe, some people on the East Coast and all the way to West Coast and Vancouver. So it really spanned the whole globe. And in terms of program, we had a lightning round on Friday evening. So really pitch your ideas, come up with what you want to do. Then Saturday, the hackathon, the hacking started. We had a few tech demos. I'll show you a little bit about that. And then Sunday, pencils down at 4 p.m. and presentations afterwards. So just to give you a little bit of a flavor of what happened and how that all went. So we had our sort of virtual headquarters within Spatial Chat. So here you see actually a little screen grab I made from the lightning round. So Spatial Chat is quite interesting. We can have local conversations based on proximity. So you actually see 3, 4, 5 different conversations happening here at the same time. Someone pitching their idea, people listening in and see, okay, I like that idea, so I'll join that group, or not, move to another group, listen what's happening there in the conversation. And we even use that for the hacking during the weekend, actually. So this is, for instance, the group, so we see Sergey showing the screen here, coding, and you see the little bubbles in the bottom. All people listening in and helping the coding. The other group actually, also in Spatial Chat, they took that to the next level and actually had 2 screen shares going on. So it was 2 people working in parallel on the same set of code. Then on top of that, we had for the participants on Saturday 4 short but interesting tech demos. So they were quite deep and a bit nerdy, going into the technology, and hopefully that would allow people to use that actually during the event. So Beam showed us again about their interoperability tools. We had Spatial, Unity, and then finally Aliverse, this new collaborative environment for VR and 3D apps. And then with that, I wanted to just whiz you through some of the project presentations. We were lucky with a couple of amazing judges. So we had some folks from the industry, both UK and US based. So thanks again for joining us as a jury. And they had the hard task of actually figuring out who's the best hack. So we'll start with Hackuble. So Hackuble was trying to, so first of all, the team. So we got Emil, Praneet, Hanshen, Yankun, and Yushi. And they were trying to marry the back of house code like C# that we all know from Rhino, from application development, desktop software, into the world of 3JS and web browser worlds. So basically, it's really hard to understand. So I just pulled up a screen grab from the presentation. So on the left-hand side, you see the web interface they built. So it's basically just a very lightweight 3D modeler, and you have a set of commands on the left-hand side. Well, actually, there's no commands. So the commands are built in C#. On the right-hand side, Emil is showing their library. You build that to a DLL, you package that, and then you can upload that into the command prompt on the left-hand side. So he's choosing the file now, and then basically the commands that you've scripted on the right-hand side in the C# will pop up as commands on the left-hand side, and it allows you to have little blocks of code to be reused as you see the commands at the top: add cube, add sphere, create building. To basically build your scripts, if you've scripted in Rhino or Grasshopper, it's familiar to you, but now being on the web and shareable with other users. And it's really that Blazor technology that they wanted to utilize. So they built a few simple apps for that, simple building. And on top of that, as well, a different interface of actually coding straight C# in the browser. So you could pull up that create new command thing and actually code in the browser right away there. I'll move on to the next hack, recent sale. So that was really about connecting PDF with Rhino. So looking at markups and how can we actually instantiate them in 3D models. So this was a team, Mark, Lucas, Johan, and Sahar were all based in Vancouver, and Amit and Nick were mainly in the US, in New York. And they were looking at text recognitions out of these PDFs and actually really treating them as a markup tool, marrying that with 3D model. So reading in the PDF, converting it to a bitmap, displaying that into model, and then actually take it off with reviewing. So they used a lot of different tools, some Python here, and some camera tools in Grasshopper, UI. And basically, I mean, first steps were aligning and figuring out those callouts, doing some image recognition and finding the structural lines, let's say. And then actually marrying these bubbles, the text bubbles, revision bubbles, clouds with the text associated with, and then on the right-hand side, you see the Rhino model, reading it in, having location information, and the text recognition. Some Python script for that, and then you see actually the text allocated back in the 3D model. Got a little video of that showing the user interface. So you got in the Rhino model your user interface, looking into these PDFs, loading them in. I'm gonna whiz through a little bit faster here. And then you can basically, in the interface, click on zoom, go to the little markup, and actually tick them off one by one, and go through that automated, rather than having manually go through a 20-page PDF, figuring out what is happening, but actually having that connection in 3D. So those were the two first ones. Then moving on to the third one, so Bonobo, and they actually won the prize for most open source project. So they tried to connect one step back. So here's the team again. Congzheng, Sergey, Omid, Ardeshir, and Sahil. And they were trying to connect the open source Blender environment, which is very well known for and on par with big commercial softwares in terms of video editing, movies, all that sort of thing, animations. But it has this fluid and rigid body motion solver inside. So how can we actually bring that whole environment into Rhino? Because that's the one big thing that Rhino kind of misses, is that timeline and that simulation set. So what these guys have done is in Rhino and Grasshopper build a plugin that made that bidirectional link to through Python, through the BPY connection in Blender to merge them together. So part of it was as well figuring out, okay, how do you actually code in Python in Blender, getting some models in and out, that interoperability going, and on the way back actually closing the loop. So from Blender into Rhino, but also from Rhino into Blender. So here's a little view of the plugin they've built. So it's dealing with the geometry and the meshes on the left, pushing it into in the middle in the actual solver, and then getting the results back to visualize back in Rhino. And then you'll have results like this little video. So actually having that explosion, that motion modeled and animated in the Rhino environment. So the next one I think is really quickly showing you how that actually goes in process. So you reference the meshes. Everyone who's familiar with Rhino and Grasshopper knows how to do that. We'll hide stuff. Enable the solver, I believe, is the next step. Yeah, so we'll enable it, so that brings up this Python little window. Connects back to Blender, does the whole simulation as the setup is controlled there from Grasshopper. And then once that's done, the next step is actually the slider on the right-hand side, is then the keyframes, the timeline in Blender, so you actually see the simulation going on in the Rhino viewport. If we move on, and they figured out some peculiarities as well. If meshes are actually intersecting, it doesn't fall, it doesn't collapse, it actually explodes. So it was a lot of fun to still figure out, I believe. But it was really, really great and promising to show there. And then the fourth one, which is also the best overall hack, the winner of the day, was this spatial scheduler. And they had the great subtitle of managing your thing, whatever that means, with unique maintenance schedules. The team was also, again, composed out of different people, different time zones: Elcin, Adam, Amit, Rolanda, and Ezgi. So they really branched all the way from Izmir to Minneapolis and Dallas. And basically what I wanted to set up is a proof of concept of an AR-enabled spatial a system of spatial persistent nodes with metadata attached to it. So and on top of that, have actually an automated notification system. So you could think of it as in your house, you manage your plant with unique like water schedules. Give it water every week, every 2 weeks. Your furniture, you can tag that, clean it every 2 weeks. But also thinking about the AEC industry, right? Actually going into mechanical units and maintenance schedules, building parts, etc. And the AR part was really important. So it was really this visual tool on your phone or on your iPad that uses the AR kit, the iOS AR kit, with that whole scheduler system. So looking at persistent nodes, etc. So they had this concept of maps, which you can share between people, you can collaborate, and as I said, the notifications. There's a couple of videos in these slides. So you would authenticate in the app, of course, within the light of 27 hours. They've skipped that, let's say, but then you basically scan your room, right? So you can create a new map, scan your room, in this case, Adam's apartment, use the built-in iOS capability of the AR kit to actually 3D scan that. And then you can, on that scan, actually tag nodes, and they're in space. They're spatially located. You can add a frequency, it needs to be cleaned every week, and that actually goes to the back end and builds up that notification system. And you can literally litter your whole apartment with these nodes, as you see. They're saved in maps, and they can basically come back after a month and actually see, okay, wait, what happened? Did I listen to my scheduler? It has an automated email notification running. And they've also, on top of thinking about the plans and the couch, they've also thought about other use cases. So facility maintenance, building inspections, individuals, but also like, yeah, all sorts of types, rebar, on-site checks, let's say, with the rest of the team. We talked about facade inspections, etc. The tech stack was quite involved, actually, I think. So it was an iOS app built on the ARKit, Placenode, and Unity. There was a whole backend server, Node.js, running with a database in the background, and then you had an automated email notifications going on the other side. And this is a list of a view of the backend showing actually these post requests. During the presentation, Adam was actually kind enough to do literally a live demo of how that works. So we see his phone, the screen of his phone shown in the middle, and he's launching the app, I believe, in a second. There we go. Sign in, and you see the video in the top right. So it's actually live, running into the app, logging in. I'm going to browse through it a little bit. And actually now he's actually scanning his apartment around himself. You see, just created a map, I believe. Yeah, there we go. That's the scanning part. And then actually adding those nodes on the fly. So it's all iOS based. It's all, yeah, if you're familiar with your phone interface, this works really, really intuitive. And then you get, so you're setting up the frequency of notifications, weekly cleaning, or, oh no, this is watering the plant. And then the node was created, and he will get his email notification every week. So they pushed it quite far within like the 27, 30 hours that they've done. They really utilized the time zones, I believe, to pick up. The one person goes to bed, the other person picks up the work, and they came quite far with that.